All right, the last set of problems. This last page, it is actually one problem made into four slides. It's a multiple choice, free response type of question here. It says this: a musician released a new song on a streaming service. In case you did not know, hey, focus with me. A streaming service is an online entertainment source that allows users to play music on their computers or mobile devices. Several months later, the musician began using an app at time t equals 0 that counts the total number of plays for the song since its release. A play is a single stream of the song on the streaming service. The table gives the total number of plays in thousands for selected times t months after the musician began using the app. At time t equals 0, the total number of plays was 25,000. At time equals 2, the total number of plays was 30,000. At time equals 4, the total number of plays was 34,000, as shown here. The total number of plays in thousands for the song since its release can be modeled by function d, where d is the total number of plays in thousands for the song since its release, and t is the number of months since the musician began using the app. So your whole first slide just sets up the problem. Nothing else. Nothing to solve there. Woo! Next slide. Given this table, it says, use the data to write three equations. Three equations that could be used to find the values for constants a, b, c for the expression d of t. And d of t is this equation right down there, that one. So how would y'all do that? They told us on the previous slide, d of t is at squared plus bt plus c. How would you write three equations? Plug in values. What's the first d of t? Nope. 25. 25 equals a, what's my first t? 0 plus b times 0 plus c, which ultimately means c would be 25 because those would cancel out. But we don't have to solve it by hand. Next, what would you plug in? 30 equals a times 2 squared plus b times 2 plus c. And then finally, a third equation would be 34. Notice, did I put any parentheses on here? No, these are the d of t values. This is d of t here. That is d of t. This is t. A times 4 squared plus b times 4 plus c. How do you get a, b, and c? Calculator, good. Go to your calculator. Let's go get the values for a, b, and c here. So I'm going to type these in as a table. You can either type in T-A-B-L-E or just hit the plus and choose table. 0, 2, and 4. 25, 30, and 34. What type of equation is that? Quadratic. I'm going to zoom fit my dots, and I'm going to choose the additive regression and choose quadratic. There it is, quadratic. By the way, because it says the r squared is 1, that means it could be a perfect model. Given our data, we have a perfect model. There's my equations there. Therefore, you must include 3 decimals, so this one we don't even have to round. It's a is negative 0.125, b is 2.75, and c is 25. I told you I was 25 because of this right there. 25. That would be the answers to A2. Questions over that? You okay if I keep rolling the part B? All right, now let's look at part B here. Part B says use the given data to find the average rate of change. The total number of plays of this song in thousands per month from t equals 0 to t equals 4 months. Express your answer as decimal approximation. Show the computations that lead to your answer. I'm going to tell you right now how so many students are going to mess this up. What do you know about AROC? What is true about AROC? The average rate of change. What's the formula for that? Change of y over change of x. Here's how so many students get thrown off though. On this table, the X values are up top and the Y values are below. Notice what's the order here? X is on top of Y, but that's not how AROC is. AROC is not X on top of Y, it's Y on top of X. So you need to make sure you invert this. We're looking for 0 to 4. So this is like X1, X2, so it's going to be 4 minus 0. So we're using these points right here, here and there. So if it's 4 minus 0, what goes in the numerator? Okay, I don't need the calculator for this one. 34 minus 25 is 9 and 4. Actually, it says as a decimal approximation, I think that's 2.25. I will check that in the calculator. I'm going to lie and say, I'm going to use the calculator. 9 divided by 4, is that 2.25? Yes. Great. That would be my answer there. Part B, it says, B2, BII. Use the average rate of change found in part BI to estimate the total number of plays for the song in thousands for t equals 1.5 months. Show the work that leads your answer. Here's what I would do. Which number is closest to 1.5? You can't use 2. Out of these that we're using for the AROC, which one's closer to 1.5, 0 or 4? 0. Okay, so here's how I do this. When t is equal to 0, we had the total number of songs was 25. What I want to get to is t equals 1.5. On average, it changes by how much? It usually it changes by 2.25. So here's all you have to do. Do 2.25 times, how much did I change to get from t equals 0 to 1.5? How much did t change by? 1.5. Just multiply that right there. That'll give you my answer. So it's 2.25 to get, you add 2.25 to get to 1, and then you add half of it to get to 1.5. So it's simply going to be 25 plus 2.25 times 1.5. Hey, did you catch why I did this? Why did I multiply by 1.5? That's how much the X changed by. So it's the average times how much it actually changed by. I'm getting 28.375. 28.375. Now it says, let A of t represent the estimate of the total number of plays for the song in thousands using the average rate of change found in part BI. For A of 1.5 found in BII, it can be shown that this value is less than D of 1.5. If you're not sure what D of 1.5 is, D is this model. You could just type in X equals 1.5. That's what the model's predicting. Which one's, you see which one's bigger? Which one's, or this says smaller. Which one's smaller? This number using the average rate of change or this number using the model? Average rate of change. That's what it says. The average rate of change is less than D. For 0 less than 2. Explain why is that. Why is it that the average rate of change is less than this one? Here's why. Because if you were to graph the AROC, again, to graph the AROC, it's the equation y equals, the AROC is your slope, times the x, and you pick a point, pick any one we're going to use. I'll use the 0, minus 0, x is a liar, that's why I did minus 0 plus the 25. When I graph the AROC, there's the AROC. Let me turn off this for a second. When I graph the AROC, because the model was concave down and this AROC's between it, the concave down, let me zoom out so you can see it, it goes higher in the middle. Do you see how it's higher than the line? It's always based off the model's curvature. Because this is concave down, in the center, the graph is higher. That would be your explanation. So since the graph of D is concave down on the interval 0 to 4, the estimate, estimates using the average rate of change will always average rate of change on any interval within 0 to 4 will always be less than the model prediction. Okay, I don't know if I'm making sense to you what I'm saying, so I'll explain it as you write it. Because the model is concave down between 0, that's 0, and 4, between the x values of 0 and 4, the model is always above the average rate of change. That's what I was trying to write here. Since D is concave down, any prediction it makes will be greater than the average rate of changes values. Okay, finally, this says the quadratic function D has exactly one absolute minimum or one absolute maximum. The minimum or maximum can be used to determine a domain restriction for D based on the context of the problem. Explain how that minimum or maximum can be used to determine a boundary for the domain of D. What does this graph have? A maximum or a minimum? I'm going to take off the A rock. What does this have? Maximum. Okay. It says that minimum or maximum can be used as a domain restriction. That right there is the domain restriction. The graph stops there. Based off that, it can be determine a boundary for the domain of D. So it's saying this graph should stop right there. At what time does this stop? 11. So what I'd say is since the absolute maximum is 11 comma 40.125, the domain would be restricted to 0 to 11.